Hi everyone, welcome back to another video. Let's take a look at this June 2025 paper 1. Question number 1 reads, consider the expression k is equal to 3n over the square root of n plus 5. Now 1.1 says, write down the values of n for which k is equal to 0. So remember, if you want a fraction to equal to 0, the numerator needs to equal 0. So 3n is going to equal 0. That means n must equal 0 as well. Question 1.2. Write down the values of n for which k is undefined. Now, for a fraction to be undefined, the denominator needs to equal 0. Now, my denominator is the square root of n plus 5. That should equal 0. Now, we square both sides. So, n plus 5 is equal to 0, n is equal to negative 5. Question 1.3, k is non-real. Now, k will be non-real if the square root is less than 0. It is imaginary. So, n plus 5 should be less than 0. N is then less than negative 5. Now, let's take a look at question 2. 2.1, simplify the following expression fully. Now what we want to do here is we want to distribute that 4p into each term within that bracket. So 2.1.1, we're going to have 4p times 2, that's going to be 8p, and 4p times minus 5x, 4 times negative 5 is negative 20, and then p times x is px. Question 2.1.2, what we want to do here first is simplify this these two brackets. So we'll apply FOIL here. Then we multiply that, then multiply that, and then lastly we multiply the resulting expression by negative 2. So we're going to have negative 2, and we're going to apply FOIL here. So 2x times 3x is 6x squared. Then 2x times negative 2 is negative 4x. Then 3 times 3x is positive 9x. And then positive 3 times negative 2 is negative 6. Now distribute the negative 2. Negative 2 times 6x squared is negative 12x squared. Negative 2 times negative 4x is positive 8x. Negative 2 times negative 2 times 9x is negative 18x. And lastly, negative 2 times negative 6 is positive 12. Now these two are like terms, we can simplify. So my final answer is going to be negative 12x squared minus 10x plus 12. Now 2.1.3, we have two different things going on here. We have this that's being squared, and then we also have the minus with that. Now if I'm looking at the second half of this equation, I can see that it follows the format a minus b and a plus b, and I know that's difference of squares, so that's going to be a squared minus b squared. Now I can apply that to this half of the expression. That means I'm going to have 3x all squared minus 1 all squared. That can simplify as 9x squared minus 1. So that's the right half of my expression. Now the left half, the first half, that follows the format a plus b all squared. And I know that a plus b all squared opens up or expands as a squared plus 2ab plus b squared. And so all I need to do is apply that and simplify the left-hand side. So this can be simplified as 4x all squared, that's 16x squared. Then 2ab, so 4x times 1 is 4x, multiplied by 2, that's going to be 8x. And then plus 1 squared, so plus 1. Then I have this minus sign, and I have my 9x squared minus 1. Now I can simplify. That's 6x squared plus 8x plus 1 minus 9x squared minus 1. Well, the minus and the minus becomes a plus. Now I can simplify. That and that are like terms. So 16 minus 9 is 7, so 7x squared, then plus 8x, and then plus 2. Now the last one, 2.2. Factorize the following expression completely. First thing I'm noticing is that I have two brackets. These two brackets are similar, they're not exactly the same. So what we can do is we can apply the sign change rule. So I change the sign outside, so the plus becomes a minus, and then I switch the inside. So that's going to be x minus 1. So I'm going to be left with x squared into x minus 1 minus 25 into x minus 1. Now, since these two brackets are the same, I can group them. So x minus 1, and whatever is left goes in the next bracket. So x squared minus 25. Now, we're not done yet because x squared minus 25 is the difference of two squares. We can then factorize that. So x minus 1, and then x squared minus 5, x minus 5, x plus 5. And that's done. Let's now take a look at question number 3. So question number 3 reads, solve for x if. Now we have 3.1.1. We have this equation, and we have x minus 3 is equal to 18 over x. First thing I'd like to do is take this across. And when you take it across, you are multiplying that by the whole left-hand side. So you have to distribute. So 3.1.1, you're going to have x being multiplied by x minus 3. And that's going to equal 18 because we've essentially taken the x across. Now distribute. You're going to have x squared minus 3x equals 18. Take the 18 over to write it in a standard form. So x squared minus 3x minus 18 is equal to 0. Now we can factorize. That's going to be x minus 6, x plus 3 is equal to 0. X is equal to 6, or x is equal to negative 3. Now let's take a look at 3.1.2. The typing is a bit off, but it should still work. So we have this inequality, compound inequality, where x is an element of real numbers and represents your answer on the number line. So what we want to do first is we want to take this over to each side. Now since it's positive, when you take it over, it's going to be negative and negative on each side. So negative 3 minus 2, and then you're going to have less than or equal to minus x, and then that's less than 0, and then you take that minus 2 over, so minus 2. Now we simplify. You have minus x greater than or equal to minus 3 minus 2 is minus 5, and then that's going to be minus 2 there. Now we're solving for x, not minus x. And so what we need to do is we need to multiply everything by negative 1. Now if we are multiplying or dividing by a negative, we need to change the sign of the inequality. So it's going to change this way. So we're going to have x greater than, and then here is less than or equal to. The minus 5 times minus 1 is going to give me 5. And in here, minus 2 times minus 1 is going to give me 2. So x is between these values. And to show this on a number line, we'll have 2 here. We will have 5 here. Since it's not equal to 2, we will have a circle. We'll not color that in. Since it is equal to 5, we'll have a circle that is colored in. And then we will just simply draw a line joining them like so. Okay, let's take a look at question 3.2. A father is twice as old as his son. Okay, so if the son is equal to x, the father is 2x. 12 years ago, the father was 3 times the son's age. So 12 years ago, the son was x minus 12. The father was 2x minus 12. But they also tell us that the father was 3 times the son's age. So we're going to take the father's age 12 years ago. So the father is going to be 2x minus 12, but he's going to be equal to 3 times the sun's age. So 3, and how old was the sun? The sun was x minus 12. So now we can solve. We can say 2x minus 12, and you distribute here 3x minus 36. Now we can take the 2x over and take the 36 over that way. So minus 12 plus 36 is equal to 3x minus 2x. So that means x is equal to 36 minus 12, which is 24. Now let's take a look at question 3.3. If x cubed plus 1 over x cubed is equal to 12 and x squared plus 1 over x squared is equal to 7, determine the value of x plus 1 over x plus 3. Now, first thing we got to do is recognize that this is sum of cubes. And so we can use the sum of cubes formula. So we can say that x cubed plus 1 over x cubed, we can factorize that as x plus 1 over x, and then remember, now if you want to factorize, you get the second bracket. The second bracket is going to be larger. The first term is going to be x to the power 2. Then because there's a plus here, we'll put a minus in the next bracket. Then we'll do x times 1 over x, and then plus x, well, 1 over x squared. So recall the formula. The formula is a plus b, or a cubed plus b cubed, is equal to a plus b, and then a squared minus ab plus b squared. So that's a formula to factorize a cube. Now, back to our question, what we need to do is we need to substitute. So x cubed plus 1 over x cubed is 12. That's equal to x plus 1 over x is part of what we want. And then x squared plus 1 over x squared is equal to 7. So we have 7. And then x times 1 over x, actually those x's will cancel. We're going to be left with minus 1. So 12 is equal to x plus 1 over x, and then multiplied by 6 minus 7, which is, well, 7 minus 6, which is 7 minus 1, sorry, 7 minus 1, which is 6. Then divide both sides by 6. You're going to get 2 is equal to x plus 1 over x. Now they want to know what is x plus 1 over x plus 3. So this we just worked out as 2. So 2 plus 3, that's 5. Now let's take a look at question number 4. Question number 4 reads, given f of x is equal to minus x squared plus 4, sketch the graph of f, clearly indicate all intercepts. So this graph is not going to be too difficult, because what we can quickly recognize is the a value is negative. Since the a value is negative, it means that the graph is going to be a sad-faced parabola. Secondly, we know the y-intercept is going to be 4. So our graph is going to look something like this. Now we need the intercepts, the x-intercepts. Remember, to get x-intercepts, y is equal to 0. So 0 is equal to minus x squared plus 4. Then we can change the signs. So 0 is equal to x squared minus 4. Then we can factorize x minus 2, x plus 2. That means x is equal to 2, or x is equal to negative 2. So that's 2, that's negative 2, that's my parabola. Question 4.1.2, write down the range of f. So the range of f is going to be what y values will we get for this function. So the range is going to be anything below our turning point. So y is going to be less than or equal to 4. Question 4.1.3, determine the values of x for which f of x is greater than 0. So they want to know, where is our graph above the y-axis? Where is it where y is positive? So if we look at our graph right here, we can see that anywhere beyond this point and anywhere beyond this point, the y values are going to be negative, right? For example, if I take a point here and bring it there, it's going to negative y value. If I take a point here and I bring it across, it's also got a negative y value. So the area where we're going to get positive y is going to be between these points here. That's where we're going to get positive y. So that's negative y, this is all positive, and that's all negative. Now, how do we write it? So we say that x must be between -2 and 2. Now question 4.1.4. Describe the transformation of f to h in words if h of x is equal to that. So what we want to do first is we will want to just simplify it. So that's minus. Now we do FOIL here. So that times that and that times that. You could apply dots, it's the same thing. So x squared minus 1. Now we simplify, that's x minus x squared plus 1. So we are going from an equation of minus x squared plus 4 to minus x squared plus 1. So our graph is going from this, where 4, and it's going now to this, where it's 1. So what's happening? The graph is shifting downward 3 units. So shifting 3 units down. You can say translating, that's also fine. Now let's take a look at question 4.2. Determine the equation of the function k of x is equal to a over x plus q with the horizontal asymptote y equals 3. So the first thing I'm going to do, I'm going to say k of x is equal to a over x plus 3. Right. The straight line f of x is equal to x plus 2 intersects with the graph at k at the point 2 and 4. So we got a point. The point is 2 and 4. We can substitute this into our equation. That's the x value, that's a y value. We can say 4 is equal to a over 2 plus 3. Now we can take this 3 over. 4 minus 3 is equal to a over 2. 1 is equal to a over 2. Multiply across. 1 times 2 is 2, so 2 is equal to a. Now we can write our formula. K of x is equal to 2 over x plus 3. And the last question of the paper, question number 5, given f of x is equal to minus x plus 1 and g of x is equal to minus 2 over x plus 2, they're not drawn to scale, R and S are points of intersection, DBQ is a line perpendicular, and they've given us these questions. So 5.1, determine the equation of the line of symmetry with a negative gradient. So if the equation is minus 2 over x plus 2, to get the lines of symmetry, I'm just simply going to read it like this. So y is equal to x plus 2, and the other one, I need to just apply a negative to my denominator. So it's going to be y is equal to minus then x plus 2. So y is equal to negative x plus 2. They want the one with a negative gradient, so this is the answer. Question 5.2. Determine the coordinates of R and S. Now, R and S, they told us are the points of intersection. So to solve for points of intersection, you equate the functions. So we're going to simply say that x plus 1, or minus x plus 1 is equal to minus 2 over x plus 2. Now what we can do is take this 2 across. We're going to have negative x plus 1 minus 2 is equal to minus 2 over x. Minus x minus 1 is equal to minus 2 over x. Now multiply both sides by x. So take that across. So x into minus x minus 1 is equal to negative 2. Now we can distribute. So x times minus x is minus x squared. X times minus 1 is minus 1. X. And that's equal to negative 2. Now write it in standard form. So take that across. Minus x squared minus x plus 2 is equal to 0. Now, since it's equal to 0, we can change all the signs just to make it a bit easier for us to follow. So x squared plus x minus 2 is equal to 0. Now factorize. X plus 2 and then x minus 1 is equal to 0. Now we can solve for x. We'll get x is equal to negative 2 or x is equal to 1. So since we can clearly see that there's 2 points of intersection, we should expect 2 values. So this is the positive one, so this has got to be 1, and this one has got to be -2. Now, to solve for the y value, all we got to do is substitute it back into either one of the equations. I'm going to substitute it back into the linear equation. So y is equal to minus into -2 plus 1. That means it's 2 plus 1, which is 3. So the coordinate here is -2 and 3. The other one is going to be y is equal to minus and then 1 plus 1. That's 0. So this coordinate is going to be 1 and 0. And then the last question, calculate the length of dB. Now the length of dB is this line right here. We want the length of this. Now we can clearly see that at dB there is a point Q, and that Q has an x value of -1. So all we've got to do really is work out what are the y values for D and B and then subtract them. So since B lies on the straight line, let's figure out what B is. So f of x is equal to, well, we want the y value. So minus and then -1 plus 1. Yeah, then that's equal to 1 plus 1, which is 2. So this coordinate B is going to be -1 and 2. Then let's look at D. D lies on the hyperbola, so we'll substitute it into the hyperbola function. So g of -1 is equal to -2 over -1 plus 2. So -2 over -1 is 2. 2 plus 2 is equal to 4. So D has a coordinate of -1 and 4. So we want to figure out what is the length here. And so we are focusing on the y values, and it's just 4 minus 2. So dB is equal to 4 minus 2, which is 2 units. Okay, that's the paper. Thanks everyone for watching. Don't forget to like, share, and subscribe. I'll see you all in the next one. Bye-bye.